What actually happens when a truly unstoppable force meets a completely immovable object? It is a riddle that has puzzled people for centuries. The confusion happens because we treat casual, everyday words as if they were strict physical laws. Our common sense ideas of what it means to be perfectly still or exert an inescapable push fail when compared to the actual laws of nature. To solve this, we must look past the philosophy and translate these concepts into the uncompromising mathematics of physics. We will launch 2 separate investigations to uncover the real scientific identities behind these opposing titans. Let's start with the immovable object. If asked to picture something completely stationary, you might think of a massive landmark, like a towering mountain peak. But relativity shows us that true stillness is an illusion. Imagine hopping aboard a rocket and blasting off into space. From your vantage point in the ship, there is no universal at-rest frame. You feel like you are sitting still, and the entire planet Earth is zooming past your window. True immovability describes an object whose velocity is impossible to alter. It is unacceleratable. This is Newton's second law of motion. Force equals mass times acceleration. We can use it to determine what makes something perfectly unacceleratable. To ensure acceleration drops to 0, no matter the force applied, the mass variable must be infinite. Under the strict laws of physics, true immovability strictly requires the object to possess infinite mass. Now for investigation B, the unstoppable force. In nature, forces like light or gravity are carried by particles transferring momentum. But the paradox implies something different, a massive, barreling object. For this object to be truly unstoppable, no push in the universe can slow it down or alter its course. Slowing down is just acceleration in the opposite direction. If this object's velocity is unchangeable, it can neither accelerate nor decelerate. If we look at Newton's law again, for an opposing force to result in 0 deceleration, we must divide by an infinite mass. This makes the unstoppable force mathematically identical to our immovable object. These 2 legendary concepts are the exact same physical entity, viewed from different starting reference frames. The 2 greatest enemies in physics are actually twins. This realization shatters the entire premise of the original paradox. In the real universe, an object with infinite mass would require an infinite source of energy. This concentration of energy would instantly trigger a gravitational collapse into a black hole so enormous that the entire cosmos would be swallowed inside it. But let's look at the pure theory. What happens if we ignore gravity for a moment and force these 2 infinitely massive twins to actually collide? We must follow the logical rule we've established. By definition, neither object's velocity can ever be altered. Because they cannot change each other's momentum, they physically cannot crash, bounce, or shatter. Instead, the 2 massive objects simply slide through each other without slowing down or making contact. The mind-bending paradox dissolves into a quiet truth. When an unstoppable force meets an immovable object, absolutely nothing happens.